Alright class, here is the assignment for March 20th, 8.1 Geometric Mean. We'll be looking at similar triangles a lot as well. Okay, so we're going to redraw this triangle separately into its three different triangles. We have the big one, the medium, and the small. And remember, in class we learned the theorem that if you have a right triangle and you drop a perpendicular segment from the right angle to the opposite side, if you drop this altitude, then this altitude divides this larger triangle into two smaller triangles that are similar to each other and similar to the largest triangle. So we're going to draw these three triangles in the same position that we see this large triangle in. First I'm going to draw the large one. I've got my right angle on the left. And I'm going to draw a medium one. And notice my short leg here is a bit shorter than the long leg. Just like it is here, this short leg is a bit shorter than this longer leg. And let's draw the small one. Okay, and I'm going to label the vertices. So the big triangle here is E, G, and F. Now the medium triangle, we have to flip it and rotate it. H is at the right angle, and at the end of the short leg is G, and at the end of the long leg is F, or you could look at it as the hypotenuse here, G to F. Nice heavy match. And then the small triangle, the right angle is at H, and the end of the short leg is E, and the end of the long leg is G. Okay, they're redrawn and labeled. Now we can write our similarity statement. So triangle EGF, EGF is similar to triangle GHF, which is similar to triangle EHG. And you could have started at a different vertex if you had said triangle GEF first, then you would just say that's similar to triangle HGF, which is similar to triangle FEG. There's multiple ways to write those similarity statements. Now we're going to separate these right triangles into the three triangles and find measurements. So let's see. There's not a lot of room to do the work, so maybe make your triangles just a little bit smaller. But I'm going to draw the big one. Notice the right angle is at the bottom right. I'm going to draw the medium one, and the right angle is on the right. I'm just doing the same position as this big one. And then my small triangle. There's my right angle on the right. Now I'm going to label all these. So the big triangle, this short leg is 6, the long leg is 8, and the hypotenuse is 10. In the medium-sized triangle, I see that the short leg here is X, the long leg is Y, and the hypotenuse, remember the side opposite that right angle, is 8. In the small triangle, it looks like Z is the short leg, 6 is the hypotenuse, and if it helps you write that right angle in there, do it. So Z is the short leg, 6 is the hypotenuse, and X is the long leg. And there's our picture. Now we can set up our proportions to solve for each letter. And there's multiple ways to set these up. I'm going to go ahead and set up using a lot of this here. So 10 goes to 6 as 8 goes to X. 10 goes to 6 as 8 goes to X. Notice I'm staying within the triangle I showed you in class. I could do 10 goes to 8 as 6 goes to X, but I can also stay within the triangle. I can compare the hypotenuse to the short leg as the hypotenuse to the short leg. you're going to end up with the same cross product positions anyway. All right, so let's cross multiply. We get 10x equals 48. If we divide by 10, we get x equals 48 over 10, and we can simplify that fraction. So I notice they're both even. I'll divide by 2. That's 24 on the top, and that's 5 on the bottom. There's our x. Okay, now we're going to solve for y. And I notice that, again, I can use this big triangle to use my first ratio. To solve for y, I'm going to put 10 goes to 8 as 8 goes to y. Cross multiply, we get 64 equals 10y. Divide by 10, and we get y equals 64 over 10. And these are both even. Let's divide by 2, and we get 32 over 5. That's our value for y. Now if we're going to solve for for z, I notice we have a pair here, 6 and z, and we can compare that with 10 and 6. So 10 goes to 6 as 6 goes to z. Cross multiply and solve. That's 36 equals 10z. Divide both sides by 10. We get z equals 36 over 10. And I can divide both of those by 2. And we get 18 over 5. So that's z. So we found x, we found y, and we found z. Okay, I need to divide this out a bit so don't run into the numbers. All right, second triangle. All right, again, I'm going to draw the big one. I'm going to try and go up a little bit so I have room to do my work. Try to leave room for your work here. There's my big triangle. And here's my medium. Notice they all have the right angle here on the right side to match this big one here. And then the small one. And I'm going to label the measurements of the sides here. So this big triangle here, this is 9 plus 4, so that's 13. The leg is 7, and the long leg is y. In the medium triangle, you see the short leg here. These two sides form the right angle, so the short leg is x. This longer leg is 9, and the hypotenuse is y. And pause this to do it yourself first. Now I'm going to go ahead and put my right angle in there because I think that helps. So 4 is our short leg, z is our hypotenuse, and x is the long leg. All right, there's the setup. Now these all three triangles are similar, so we can make some ratios and solve some proportions. All right, if I'm going to solve for x, let's see. I don't see a pair. It's like if I try to compare 13 to z as y goes to x, I have too many variables. I could compare 9 is to x as x is to 4. That will work because this is a z, by the way. It looks kind of like a 2. That's a z. I can compare 9 is to x is to 4 because it's the same variable. So let's do that. Of course, it's going to create a geometric mean. So 9 is to x. I'm going to go from the long leg to the short leg, and then I'm going to go from the long leg to the short leg. And there's a ratio with just one variable. And that's our geometric mean here. So x squared equals 36. We take the square root. We're only using the positive root. Right? X equals 6. So x equals 6 and x equals 6. All right, now we're going to solve for y. Now we have 13 is to y as y is to 9. We could use that ratio because they have the same variables. We could also use, nope, I think that's all we can use at this point. So I'm going to take 13 is to y as y is to 9. And we have the same variable in there, geometric mean, y squared, and geometric mean between 13 and 9. So 13 times 9 is equal to 117. Now I'm going to take the square root of both sides, so we get y equals the square root of 117. Right? Y squared equals 117. Take the square root of both sides, and I'm done. Okay. Oh, actually, is there anything in there that can be factored out? Yes, actually, that can be simplified. So if you look at your factor pair sheet, you'll notice that 117 can be written, well, 9 times 13. I could have used it like that, left it like that. Anyway, so there's my perfect square factor. And I get y equals 3. I take out the 3, and you're left with the square root of 13. So that's our y. So we can simplify that radical. I know it's divisible by 9 because we had 13 times 9 to create 117. So I could have just used those two factors right there. Okay, now z. Z is here, and z is here, and z is here. Here we have a pair. 13 is to z as z is to 4. I can use that pair. I tend not to use the pairs that I've solved for if I don't have to, because what if I made a mistake? Plus there's a radical in there. Okay, so 13 is to z as z is to 4. Now I can cross multiply, and we get z squared equals 13 times 4. If I take the square root of both sides, I get z equals the square root of 13 times 4. Notice I didn't multiply it out this time, because I see that perfect square factor, and I'm going to want to take that out. Oops. Okay, so z equals, I can take that out as 2 rad 13. Okay. Those are our variables for that one. Let's do number 4. At any time you feel like you need extra paper, just do it on a separate piece of paper and staple it to it when you turn it in. Okay. Again, I'm going to try to put my triangles up a little higher so I have room to do the work. Alright, there's my big right triangle. Here's my medium right triangle. And here's my small right triangle. And let's label the parts. So in the big right triangle here, this is going to be x plus 5. Right, that whole side is x plus 5. This is z, and this is y. Then in the medium-sized triangle, this short leg is 10. This medium-sized triangle, the short side is 10, and the longer leg is x, and the hypotenuse is y. And again, pause and try to do this first by yourself. Then check your labels. Okay, then the small triangle is the short side is 5. The hypotenuse is z, and the long leg here is 10. The long leg. Okay, there it's labeled. Now we need to find x, y, and z. So if I look at x, I know that I could say here's an x and here's an x. X plus 5 goes to z. No, as x goes to 10, that's too many variables. Oh, here's this pair right here. And this pair right here I could use. That way I just have one x. And I don't have any other variables. So we could compare x to 10. X to 10 as 10 is to 5. Another thing we could do is maybe solve for y first and then plug that in, but there's probably multiple ways you could do this. Alright, let's cross multiply. 5x equals 100. Let's divide by 5. we get x equals 20, and there's our x value right there. Now we're going to solve for y. We can use, I'm going to make that look more like a z. Okay, so we can use, well, I can't say y is to 10 and z is to 5 because that's two different variables, but we could say maybe, we could do y is to x and z is to 10 if I put in the value for x. Or we could do, I think we're going to have to do, well, I'm going to just do this. I'm going to say that x is equal to 20. And up here, x is equal to 20, so I add it to 5, so that's 25. So that gives us some values we could use. We could take 25 is to y as y is to 20. So in this case, we do need to plug in the value. So 25 is to y as y is to 20. And that'll work because it's the same variable. So we get y squared equals 20 times 25. Well, that's equal to 500. So y squared equals 500. Take the square root of both sides and we get y equals the square root of 500. And I can simplify that because that's 5 times 100. So I can simplify that radical. I can take out the perfect square, so that's 10 on the outside and add 5 inside. So if you get, the square root of 500, you're going to need to simplify that radical. Now, I could also do the Pythagorean theorem here. So if you wanted to do the Pythagorean theorem, that would work. I just took a minute to check my work. So once we found x, you could use the Pythagorean theorem here to find y. But I'd like you to not do that if you can help it for a little while and set up these proportions. But sometimes you just have to use the Pythagorean theorem. Okay, so that was y. Now we need to find z. So z. Well, here we could use the Pythagorean theorem, right? But if we ignore that and we use y equals 10 rad 5, we could compare y is to z. Let's see, 10 square root of 5 is to z as 10 is to 5. Let's just use the Pythagorean. I think in this case it might be easier. So we'll just do leg squared. So z squared equals leg squared plus leg squared. That's equal to 25 plus 100. It's equal to 125. So z squared equals 125. Take the square root of both sides and you get z equals the square root of 125. And this is equal to, this has to be simplified. So 25 times 5, take out the 5 and we get, take out the 5 and we have the square root of 5 left on the inside. The square root of 25 comes out. Alright, so that's z. So I take it back. Maybe in this case it'd be easier to use a Pythagorean theorem. Okay. Next one, number 5. Redraw our triangles. I did it again. Here's our hypotenuse, short leg, longer leg, and then our medium. This is not, I'm trying to leave enough room for the work. Okay, so there's medium. It's going to get very small very fast. Okay, tiny, tiny. And let's label the sides. this whole side of this big triangle is 13. This leg here, the shorter leg, or the leg that comes down vertically, is 5, and this bottom leg we don't know. The medium triangle, we have the measurement. This leg here could be 13 minus x. This could become 13 minus x. Let's do it. We'll see if we need it. 13 minus x. Oops, I put it on the hypotenuse. So 13 minus x is this leg right here. 13 minus x. And then the small triangle, we have x for the short leg. Right, this is our short leg, and 5 for the hypotenuse. Okay, so I see a ratio or a set of proportion, a set of ratios we can use. We could use 13 is to 5 as 5 is to x. We don't have to use this middle one here. So 13 is to 5 as 5 is to x. And cross multiply and solve. So 13x equals 25. Divide by 13. And x, oops, by 13, and x equals 25 over 13. And that's all we needed to find, was just that one. So just drawing the different pictures here can help. Okay, number 6. This time the triangle is standing up, sort of on its, the right angle's on the left, so let's redraw it in that same orientation. The big triangle has the right angle on the left, and sort of a shorter leg down here. Then let's draw the medium, and the small. Being very careful to make my right angles look like right angles, okay? And make one leg longer than the other because it's longer in this picture. Okay, so we have x down here. If we look at this whole triangle, we have x at the bottom, and then we have 30 plus 10 is 40. In the medium triangle, we just have the long leg, which is 30. Okay, this is the longer leg. This is the shorter leg. So we don't have a measurement for that shorter leg. We only have a measurement for the longer leg. The small triangle, the short leg here. I'm going to go ahead and draw that 90-degree angle in there. Short leg here is 10, and the hypotenuse opposite that angle is x. And you always want to make sure you label it right, because if you don't, then you get the wrong answer and have to redo it. Okay, we're going to solve for x here. I see we have an x here, and we have an x here. We could use these two ratios because the variable is the same. So I could say x is to 40. I mean, you could do this multiple ways. I could say x is to 40 as 10 is to x. You could have said 40 is to x as x is to 10. Same cross products. Okay. Anyway, we'll go ahead and solve it, either one. So this is 40 times 10. That's 400. And we have x squared. Okay, so I'm going to take the square root of both sides. And we get x on this side, and we get the square root of 400 on this side. We are going to need to simplify that. I know that there's a perfect square in there of 100. So that's actually, look at this. I could write this as the square root of 4 times the square root of 100, right? Well, the square root of 4 is 2, and the square root of 100 is 10. So actually, we can take out the 2 and we can take out the 10, and so our answer is 20. So the square root of 400 is a perfect square. 400 is a perfect square. Maybe you saw that right away, but if you don't, you can simplify it by breaking it down into other perfect square factors, and then if you need to do it again, you could do it again. But this is a perfect square and this is a perfect square, so I just got 2 times 10. Okay. Next page. Separate this triangle. Alright, because I'm going to try and write it up higher. The right angle is on the left, the longer leg is on this left side. And I'll draw the median. And I'll draw the small. Okay. And this is Y. This is 6, and this is Z plus 3. The medium triangle is this one up here, so the right angle there. The longer leg is Z. The shorter leg is X. And like I said, I hope you're pausing this first to redraw it yourself first, because that gives you the practice that you need. This is Z. And then the small triangle, the short leg is 3, the longer leg is X, and the hypotenuse is 6. Okay, we have to solve for all 3 variables. So if we're going to solve for X, we could, I don't see a ratio, X to Y as X is to 6. In this triangle, X doesn't have a number we can compare it to, so we end up with we have too many variables. X is to Y, for instance, as 3 is to 6. That's not going to work. We have 2 different variables. I would say that we could do, can we do Y first? No. Can we do Z first? No. Well, it looks to me like we're going to use the Pythagorean theorem to solve for X. Maybe you see something I don't right now, but I can use it. I can always look and see, can I use the Pythagorean theorem, and I can solve for X that way. So X squared plus 3 squared, right? Those are the 2 legs, and that equals 6 squared. So that's X squared plus 9 equals 36. Subtract 9. And we get X squared equals 27. Take the square root of both sides and we get X equals the square root of 27. Alright, so we found X. Now I am going to simplify that because I know it has a perfect square factor, 9, and I can multiply that by 3. Right? So I can take the square root of 9, that's 3, and I leave 3 on the inside. So there's our X value. Well, if I put X here, that's 3 rad 3. Can I now find Y? Well, we can compare this side to the Y as the 3 is to the 6. Right? Then we just have one variable. So you're looking for either a proportion that is missing just one number or has the same variable in it. Okay, in this case we can compare 3 rad 3 to Y, the short leg to the hypotenuse, as this short leg is to this hypotenuse. We could do that. And we could solve for Y. So I'm going to cross multiply, and we get 6 times 3 rad 3 equals 3Y. Let's be careful here. 6 times 3 is 18. The numbers on the outside stay on the outside, and that equals 3Y. And now to get Y by itself, I have to divide both sides by 3. Okay, so I'm just going to rewrite it up here. 18 rad 3 equals 3Y. So if we divide this by 3, that cancels. If we divide this by 3, remember, you only divide the outside with the outside here. So that's 6 rad 3. And that's our Y. So Y is equal to 6 rad 3. solving for z, we have some choices. I think I would prefer to use the Pythagorean theorem. We have this value and we have this value. Let's solve for z using the Pythagorean theorem. So, how are we going to set this up? I'm going to get rid of that. In order to solve for z, I need to take the leg 3 square root of 3 and square it, add it to z squared, and that's going to equal 6 rad 3 squared. Okay, so leg plus leg equals, leg squared plus leg squared equals hypotenuse squared. When we're squaring this, I square the outside, which is 9, and rad 3 squared is just 3, plus z squared equals, this is the power rule. I'm going to square the 6, which is 36, and I'm going to square the square root of 3. Remember, the square root of 3 squared just equals 3. So this is going to be 36 times 3, squared the outside, and I squared the square root. This is 27 plus z squared equals 36 times 3 is 108. Okay, subtract 27. Z squared equals 81. Oh, that's nice. Now if we take the square root of both sides, we get z equals 9. 81 is a perfect square. Okay, so maybe you saw a different way to do it, and if you did, I'd be happy to see it on your work, or you can show me. Okay, number 8. We're going to separate the triangles to find x in terms of a and b. Alrighty, I'm going to redraw the triangles in the same position that this big one is in. So I'm going to draw the big one. Carefully. Here's my right angle. Then I'm going to draw a medium one in the same position, and I'll label it later. That's my medium one. I'm going to draw my small one. Now the big triangle, this is A plus B. It's the only side being low. In the medium triangle, we have this shorter leg is X. Right, the shorter leg is X, and the longer leg is B. And in the small triangle, the short leg is A, and the long leg is X. Okay, can we solve for x? We don't even need to use this. Let's not even use this triangle. I see an x and a b and an x is, we're doing this in terms of a and b. So x goes to b as, oh, wait a second. It's not going to work. I see what I did. I labeled this incorrectly. On the small triangle, A is the small leg and X is the long leg. Aha! Will not be my first mistake on these, I'm sure, or my last. Okay, so B is to X as X is to A. We're trying to relate X to A and B. This will work. So we're going to solve for X. Cross multiply and solve, and we get X squared equals B times A. Take the square root of both sides, and we get X equals the square root of B times A. And sometimes people write it with in alphabetical order, A times B. That's X in terms of A and B. Okay, let's do that again over here. Draw the triangles. This time the short leg is on the left. This is the long leg. Here's my right angle. Let's draw a medium one in the same position. Let's draw a small one in the same position. Okay, so the big triangle, the hypotenuse is A, the shorter leg is B, and we don't have a measurement for the long leg. Then here for the medium triangle, we don't have a measure. Well, I guess we could say that this long leg here, this long leg, this medium triangle is A minus X. Hopefully we won't need to use that. This piece right here is A minus X. And we don't have a short leg measurement, and we don't have a hypotenuse measurement. Then the small triangle, we have a short leg of X. We don't have a measurement for the long leg, but we do have a measurement for the hypotenuse, which is B. I'm feeling like I made a mistake here again. Let's see. This is the big triangle, so that's the shorter leg is B. Longer leg, nothing. That's A. Medium triangle, A minus X. Short leg, nothing. Hypotenuse, nothing. Small triangle, short leg is X, long leg we don't have a measurement, and B goes here. Okay, so we're going to set up an equation to solve for X in terms of A and B. Okay, I had to check something, but let's write our proportions here. We want to write X in terms of A and B. So I'm going to use these two ratios. B is to A as X is to B. Cross multiply and we get B squared, right? B times B is B squared. And A times X is AX. Solving for X, we divide both sides by A. So we get X equals B squared over A. Find the geometric mean between 1 and 9. Well, the geometric mean is taking the square root of the product. So you multiply them together and take the square root. And that's the square root of 9, which is a perfect square, so that's 3. Number 10. Find the geometric mean between 6 and 4. Well, that means take the square root of their product. So that's equal to the square root of 24. We can simplify that because it has a perfect square factor of 4. So this is equal to, let's rewrite it back as 6 times 4, because we're going to now take out the square root of 4, right? That's 2, add 6. So the answer is square root of 24, because you multiply them together and take the square root, but you do need to simplify that radical, and that's what you get. Okay, if the geometric mean between 5 and a number is 10, find the number. Okay, so between 5 and a number, let's call the number X. So the geometric mean between 5 and X means take the square root of 5 times X. And that answer is going to be 10. So the geometric mean between 5 and a number means you take 5 and that number and then take the square root of it. Alright, so that's going to equal 10. To find X, let's square both sides. And we get 5X equals 100. Divide by 5, and you get X equals 20. Let's check it. 20 times 5 is 100. Take the square root of that, that's 10. The next one, we're going to do it exactly the same way. The geometric mean between a number, let's call it X, and 8 is 4. So that means the square root of X times 8 is going to be equal to 4. The geometric mean between X and 8 means you multiply them together and take the square root. That is going to equal 4. Okay, to solve that, square both sides. So we get, let's make the 8 on the left-hand side. 8X equals 16, right? Square it, square it. It just gets rid of the radical. And then divide by 8 and you get X equals 2. Checking it, 2 times 8 is 16. 2 times 8 is 16, that number X is 2. So 2 times 8 is 16, the square root of 16 is 4. And back to our 45, 45, 90 and our 30, 60, 90. Remember in 45, 45, 90, L equals L, and the hypotenuse equals the leg times square root of 2. And here, S equals 1/2 of the hypotenuse. The hypotenuse equals 2 times the small side. And the long leg equals the square root of 3 times S. Let me write that. S rad 3. And you can use these formulas to solve for missing pieces as well as these. Okay, so here we have a 45, 45, 90. We're given a leg, so that means this other leg, x is equal to 13. And the hypotenuse is going to be equal to 13 rad 2. Take the leg and multiply it by rad 2. 14, 45, 45, 90. We're given the hypotenuse this time, so if I want to find the leg, I need to take the hypotenuse and divide it by the square root of 2. So I'm going to take the leg and divide by square root of 2. I want you to notice that we have a radical on the bottom, so we need to simplify that. So we'll multiply the top and the bottom by rad 2. And we get 30 rad 2 on the top and 2 on the bottom. Now these numbers on the outside can be simplified, so we get 15 rad 2. Divide 30 by 2 and you get 15. So here we have a 30, 60, 90. So we're given the short leg. Okay, well, the short leg is 3. That means that the hypotenuse is 2 times 3. So that's 6. And the long leg is equal to that short leg times rad 3. And we're done. Number 16 is a 30, 60, 90 again. This time we're given the hypotenuse. So if the hypotenuse is 34, then the short side, you always want to find the short side first. The short side here is equal to half of that. So we take half of 34, so y equals 17. And then if we want to find the long side, you take that short side and you multiply it by rad 3. And we're done. Here we have a 45, 45, 90. So the two legs are going to be the same, but the hypotenuse is 10 rad 2. So the leg is going to be equal to the hypotenuse divided by rad 2. So we take the hypotenuse, 10 rad 2, divided by rad 2. Going from the hypotenuse to the leg, so divide by rad 2. This cancel up, and we're left with 10. So x equals 10 and y equals 10. Number 18, 30, 60, 90, and this time we're given the long leg. So if we're given the long leg, to find the short side, remember you always want to find the short leg first. The short leg equals the long leg divided by rad 3. You just need to change this formula so that it's the short leg equals long leg, just divide both sides by rad 3 in other words. Okay, so anyway, this is the formula. Short leg, so if we want to find it, we take 25 rad 3, divide by rad 3 to get here, cross those out, and we get 25. Okay, to get from the long leg to the short leg, divide by rad 3. If you divide by rad 3, they just cancel. And then the hypotenuse is twice the short leg, so that's 50. And we're done. That is a very challenging assignment. I hope you got some good learning. Thank you. See you next time.